Everyone, and welcome to our live stream on building more accurate AI apps with Arize and Langflow. Let me just bring up a little slides here to share with the group. All right. So today we got a couple speakers. Myself, Alejandro Cantarero. I'm field CTO for AI at DataStax. I work with lots of DataStax customers on kind of what they're doing with Gen AI and how to be successful with Gen AI. And I'll let my friend here, Rich, introduce himself.
Hey everybody, Rich Young. I'm a Director of Partner Solutions Architecture at Arize. Glad to be here. Yeah, we've been working pretty closely with DataStax and Alejandro, doing some good stuff here that we hope to share with you guys. So great to meet you all.
All right, and then one kind of important housekeeping item. Please feel free to use the chat, but if you're on the live stream app, you'll see there's a section for Q&A. If you have any questions, please put them in the Q&A section. It's easier for us to find them, make sure we can get you answers to kind of everything you're wondering about. It happens to be accuracy week at DataStax. So this live stream is one part of a bunch of things we're doing around how to kind of build accurate AI. If you're interested in this topic, please go check out kind of everything else we're doing. We've got information on things like hybrid search, how to select an embedding model. There's some content coming later this week on re-rankers and how to use them. So a whole bunch of stuff going on.
Yep, and on the Arize side, we have an Observe conference coming up June 25th. Really excited about this. It's going to be it's held in San Francisco at the lovely Shack 15 venue. We're going to be basically the world's largest AI observability conference. It's going to bring together a community of agent builders, thought leaders in the AI space, people sharing best practices and valuable experience around building, deploying, running agents in production. We're going to have great thought leaders from NVIDIA, AWS, Google, Microsoft, Llama Index, Cree AI, Datadog, etc. It'd be great to have you there. And I included a promo code here. Make sure you scan the QR code. We'll also put a link to this as well. A really great event that we're super excited about at Arize. Glad to see you guys be there.
All right. So today's mostly about building, and we're going to show you how to kind of build some agentic AI systems and then how to measure them and how to kind of, study what's going on with the accuracy. So I'm not going to do too much on the slides, but just a little bit to kind of set kind of what's going on. So, this is what kind of we see kind of in the conversations we have with both customers and developers, right? About like where are the struggles currently with kind of building AI systems. One of the biggest ones, low accuracy, right? That can be hallucinations, that can be incomplete answers, different kind of flavors of this, but that you can't quite get the accuracy you're looking for. The next slide, I'll talk a little bit more about the second one, the gap from POC to production. But basically that it's really easy to kind of build a POC and kind of show that something kind of works, but a lot of challenges when you try to go all the way to production. And then a lot of tools in the ecosystem. There's a very fragmented ecosystem. A lot of what we're going to be showing you today is kind of how to bring a bunch of those tools together really easily to kind of solve problems. On the POC to production gap, this is just an example of kind of some of the things that we hear and we run into when we're talking with developers. So again, POCs often tend to come together quickly, and we're going to build a POC of something today in the next hour, and to kind of help prove that point, it's really easy to build something basic. These questions in the middle are things that kind of come up as people then try to kind of move their way into production. So struggles with accuracy. Sometimes it's not even just about accuracy, but whether or not the AI app is even delivering the business outcome you're looking for. Then how do you start measuring how well all of this is working? How do you pinpoint where the problems are in the system? And then those are kind of the areas we're probably mostly focused on today. But then there's also, of course, like how do I scale this to serve, thousands or millions of users? How do I deal with security, privacy, regulatory compliance? We're not going to get into those topics today, but things that often come up as people try to move towards kind of building apps into production.
And this is, I think, where, kind of bringing the Arize point of view. So, one of the key things we talk about sort of, from development to production is that sort of this sort of chasm in between, right? And Arize is kind of focused really on being kind of a single platform that kind of covers both the development and production workflows. And sort of what I mean by that is as you're building agents, and we'll kind of go through this process, and we'll kind of show you this today in terms of Langflow and how, but you kind of start with, creating data sets that you use golden truth data sets. You iterate and kind of improve and build your agent, and you can run evaluation experiments, understand sort of, quantify the improvements or the accuracy of the agent. And then once you get to a stage where you actually deploy that agent, there's the other side of being able to continuously evaluate the app using the same kind of evaluations that you're running in the development side. Be able to monitor and understand sort of where issues are arising, and then kind of the key kind of insight that we've seen across a lot of our customers is being able to identify these kind of failure points that are coming off of your production data, the real data that's coming from users running in the system, but automatically flag those failure points, and then use that production data to then drive that development workflow again to kind of fuel this cycle. So it's a kind of a continuous. The production data itself fuels the development cycle as well, and you see this sort of iteration between development and production. So we help close that gap, and I think we'll be able to show some examples of how we'll be able to do that today.
All right. So like I said, that's pretty much it for slideware. So, what are we going to do with the rest of our time? So we're going to show you how to build an agentic chatbot that kind of uses Astra DB and Langflow to work across some real data. We're going to learn how to understand that agent behavior through Arize. And then we're going to create an evaluation framework to measure the accuracy of all of this. And that'll be done with kind of a combination of Python, Langflow, and Arize. And then we're going to show you how to run a bunch of experiments. And we've preloaded several experiments just to kind of show you how quickly you can kind of evaluate a lot of different things and kind of understand what works and what doesn't work for your AI app. Just a kind of quick overview of the products we're using. As we mentioned, like Arize, is kind of the observability and evaluation platform that we'll be looking at. Astra DB is a cloud NoSQL database with vector search that we'll be using. And then Langflow is an open source tool that is a low-code tool for developers for building AI agents and AI workflows. All right, so with that, we will jump over to some materials here. So the one thing I just wanted to kind of share really quickly is, again, this is all about being able to get everybody here like hands-on and use these tools. So we have a GitHub repo that has everything that we're going to talk about. It has the data sets we're using. It has Jupyter Notebook to help, work through kind of some of the code samples. And then these JSON files are flows you can actually import into Langflow to kind of run yourself. Additionally, we have a blog that was published a few weeks ago that runs through a very similar set of exercises that includes code samples and everything you kind of need to kind of do this on your own. So these are resources that are available to you. Now I'm just going to kind of jump in and kind of get started with building all of this out. So this is what's on the screen now is Astra, our cloud web portal for the database. You can sign up at astra.com. I'll share the links in the chat. Everything we're doing here works on our free tier with no credit card. So again, we really want you just to be able to play around. There's kind of nothing you really have to do. I'm going to just literally go through and set up everything really quickly. So you come into databases, you say create a database. I can give it a name. I will put this in AWS and in one region and hit kind of create database. This takes about a minute or two for this to spin up. So I will then jump over to Langflow while this is spinning up. So this is Langflow, as mentioned, open source project. You can kind of install it with pip. There's instructions on our docs website. We've also recently launched some alpha versions of desktop applications that you can install. There's one available for Mac OS, and I believe the Windows one is not quite out yet, but we'll be releasing very soon. So a couple different ways to use this. Integrating Arize with Langflow is fairly straightforward, and there are instructions on our documentation. But essentially, you go into the Arize UI, you get a couple key values, and you set those in an environment variable file. And then when you run Langflow, you just point at this environment variable file, and then you'll be up and running with kind of everything being collected. I will not show you my environment variable file because I don't want to have to like regenerate my keys afterwards, but that's really all it takes to get it set up. So now, let's go over, and I've got a project called Accurate AI Apps. These are the final flows that we're going to do, but I'm going to actually build everything from scratch so you guys can see how to do it. So I'm going to click this new flow button, and you see we've got a bunch of templates, and I'm going to start with this vector store rag template. So there's a lot of stuff on the screen right now. The top row is basically a chatbot. The bottom row is a data ingest. I don't want to use the chatbot right now, so I'm just going to delete this whole top thing and just focus on the bottom. So let me get rid of that and zoom in here. So you'll see a few things on the screen, right? So we've got the ability to process files, a text splitter, OpenAI embeddings for the embedding models that we're going to use for this, and then a vector database, which in this case is Astra DB. So to set this up, you need to bring in, you can copy and paste your API key in, or you can use these global variables. So I already have an OpenAI key defined. I need an application token for the Astra. My database is now done. So if I come back over here, I can now see that test DB has been created. I can click this generate token button. I can give it a description, and I can click generate token, and I can copy that out. And then that's all I will need to kind of connect. So if I come back over to Langflow, I will now show you quickly how to set up one of these global variables. You go to settings, go to global variables, say add new, I'll call this Astra test DB. I'll paste in the value and click save. And now if I go back to the flow that we were working on and zoom in here, I can now add my application token, which is this Astra test DB. If you wait a second, it's now going to connect and see what databases are available. So there's my test DB. And then we need to create a collection. We don't have one now, so I'm going to make a new collection, which we can call OpenAI small. I'm going to bring my own embeddings, and you need to know what the dimension of the vectors are that you're going to be using. I need to just go over to my other doc here and copy. So this particular data set, oops, I have to open that back up. Okay, the dimension is 1536. As I said, OpenAI small, hit create. This takes a, oh, did I lose my, yeah, let's let that go. Okay, it takes a minute to run the collection creation. So this will take, a minute for this to show up here. You can click the refresh button. There it is, OpenAI small. So I select that. And now I'm going to select all the files that I want to upload. So in this case, in that GitHub repo that we shared earlier, there's a data file and there's text files. We're using the Stanford question and answer data set here as an example. They have a nice dev version of that data set that's pretty small. It has 35 Wikipedia articles in it, which is what we have here. So I can add those here and say select files. And then if I click the play button here on the last component, it's going to kind of run everything. And so you can see now the Astra DB component is highlighted and it's loading the data. This will probably take like 2 minutes to run, so I'm not going to wait for it to finish. But if I come back over here, I've already loaded that data set. So if I click on Data Explorer and I go to Squad Small OpenAI, you can see I've got 1,400 records of dimension 1536. And then I've got a bunch of example records here. So, here's one that's talking about Economist Intelligence Unit ranking livable cities, and that Warsaw is a top-ranked city, for example. Yeah, so we've loaded all the data. And if I come back here, you can see I loaded 2 data sets. I loaded OpenAI's small embeddings, and I loaded OpenAI's large embeddings so that we can run an experiment and test to see, hey, does it matter if we kind of change the embedding size? So now, if I come back over here, I'm going to show you how to build the actual kind of agentic chatbot. So we'll start by doing a new flow, and this time we're going to do a completely blank flow, and we're going to use the different components in the left here to kind of build this. So if I search here, I'm going to start by building an agent. All right, and then we'll start by building kind of just the most simple thing we can, which is just an agent with a chat input and a chat output. So you drag in these components, you connect the input there, you connect the output there. You need to have your OpenAI key. And then if we click here, we can see what the agent instructions are. So the default ones are very simple. really just tells it it's an agent. And now in Langflow, you can hit the playground. You can say, hi, what do you do? So I'm just trying to see, hey, does it look like there's kind of an LLM in the mix here? So this is going to respond, and you can see, okay, now the LLM is answering. Great. So, but what we were trying to do, right, was work with this kind of test data set and see, if we can build a chatbot that's accurate over the particular data that we care about. So now I'm going to quickly add a tool here, which is our vector database. So as you remember, we had Astra before. Oop, not wrong key. We set the OpenAI key. Sorry, OpenAI. Yes, this is Astra. We need our Astra token, which is that one. And again, it will then automatically populate which database. So we select our database, and then we're going to select the collections that I had previously made, which is this small collection. Now we need to add the vector search needs to know which embedding model we're using. You can see here, we can click on embeddings. Langflow has support for many embeddings, Cohere, Google, Hugging Face, IBM Watson, Mistral. You can run things locally with Ollama, a lot of options. We're going to use OpenAI and connect that in. And again, you need your OpenAI key. Now in Langflow, pretty much any component, if you click on it, has this tool mode. So you can toggle on tool mode, and then that will make this able to connect into the agent tool. One really powerful thing is Langflow supports multi-agent in the same way. You can bring in another agent, you can toggle on tool mode, and you can connect an agent as a tool into another agent, right? So now you have kind of multi-agentic systems talking to each other. For today, we're just going to use this tool that's kind of the Astra database. And now we're going to modify our instructions to get something a little bit more advanced here. So let me copy and paste in our agent instructions. All right, so these are long, and again, they're in the GitHub repo, so you don't need to read the whole thing. But what's important here is we're just telling the agent that its job is orchestrating tools and other agents. We're not telling it what its actual task is to do other than answer questions that come in using tools that it's got available. This is really important because we're letting the agent be very dynamic in how it's selecting and using tools rather than being prescriptive and telling it exactly what it needs to do. And then you can see, because we really want to focus on the quality of our data sets, we're telling it you must actually use the tools that you have available. That's really important to us. So that's been saved. And then one thing I want to do here is, under the hood, every component in Python in Langflow is just Python code. It's a function that defines what the interface looks like, and then it's a function that defines the execution, which means you can come in and kind of change anything. So Langflow by default only has one type of agent. But I'm going to actually just rename this thing an orchestrating agent because it has a very specific purpose. So it's that easy to kind of go in and change things with code. And now let's ask a question to our data set that answers one of the Wikipedia articles that we have. So I'm going to start a new chat session. I'm going to ask who was the first Huguenot to arrive at the Cape of Good Hope. So this is running. It gets the answer. But it doesn't look like it actually is using our tools. So there's one step that we kind of forgot to do, which is when you set up a tool, you have to edit the tool descriptions to tell it what to do. So right now, this has a very generic description that it's searching Astra DB. So instead, I'm going to change this to search a vector database with a set of knowledge base articles on a variety of topics. All right, so let's save that change. Let's come back to the playground and let's run this one more time and see if we get something different. Okay, so now you can see, now it says, hey, I'm accessing Astra DB search documents. Great, it's trying to use our database to answer the question, and you get back an answer. All right, now let me ask another question, which I will copy and paste from over here, which is, what is the most popular song from the Dave Matthews Band? Now, it turns out we do not have any Wikipedia articles about the Dave Matthews Band. So let's see what happens in this case. So we're searching, and you see it still answers the question, and it says Crash Into Me is the most popular song. So in this case, I really don't want it to answer the question if it's not using the data that we had populated, because we're trying to assess the quality of our data set. So I'm going to make one more change to our agent instructions, which is I'm going to come in here, and at the end, I'm going to basically tell it, if you don't have information from the tools that you have access to, just do not answer the question and don't use your internal knowledge to answer. So now that I've made that change, let's come in and let's try our Dave Matthews Band question one more time. I will do this in a new chat window because I don't want it to rely on chat history that already has the answer. So let's see what it does this time. Great. It says I don't have access to the information. That was exactly what we wanted it to do. So now that we have kind of a simple chat with a tool going, I'm going to hand off to Rich so he can kind of show us how you can use Arize to kind of dig in and get more information about this. And one thing I should have done before I did that was give this thing a name. Chat, live stream, save. All right. So that in Arize, it'll show up a little more cleanly on kind of what we're doing. All right. Then Rich, I will stop sharing my screen and hand it off to you.
Awesome. Let me share my screen now. Okay, if I get this right. All right, can you see my screen? Well, you
Yes.
can? Okay, cool. Yeah. So now we're in Arize. As you saw earlier from Alejandro's setup of basically the Arize tracing setup, all he had to do basically was assign some environment variables with the proper keys there. And traces are basically automatically flowing into Arize. So setup is really easy, and all of the transactions that you saw basically Alejandro run, those are all captured, and we have traces for those. So if you think about traces, really that gives us kind of observability into exactly what's happening under the hood. So Langflow makes it really easy to kind of create these UI-based kind of configurations for the agents and kind of test things and test flows. But what Arize can do here is give you that visibility to kind of understand at kind of each step of the process what's going on. So I just kind of picked a trace from our pool that we've been testing with here. And so you can see a kind of waterfall graph, and basically a trace itself is made up of a kind of parent trace that you see on the outside. There are different units of work that are automatically, all the function calls, all of the LLM calls here, the tool calls, all of the choices made for any of these kind of queries that are being run are automatically captured as what we call spans under these traces. So they're all linked, and you can kind of see how they are connected, and you can basically follow the entire flow. So as these multi-agent, as you're using more and more complex kind of workflows and more non-deterministic workflows, it becomes really important to basically have this visibility to understand at least kind of what's going on, right? And so within each span, we're capturing a number kind of pieces of information. So the first is performance and latency. So you can see that this query here, or this entire transaction, took about 6.76 seconds, and you can see the breakdown of kind of each of the spans. So if there's anything that's long running, or anything that times out, or there's any issues kind of from performance perspective, you can see that immediately. And then we also track the prompt tokens for LLM. So that's important for you as being able to track, this from a cost or just usage perspective, right? How many tokens are being used on each call. So we track these and allow you to report on these as well. So you can keep track of these pieces of information. And then we track what are called attributes across each of the steps. So in this agent workflow here, I'm just going to kind of jump through real quick. So there's a few things happening here, but the main pieces are, here's the input question that's being asked of the agent initially. It jumps over to and we process the information and passes that to the LLM, the OpenAI chat LLM here. And you can see that we are kind of parsing out or making these the system prompt here that you can see. You have the user prompt or initial question here that's being asked, and then you have the output message. So in this first example, with the query, the first kind of task was for the LLM was actually to choose, or the agent is actually to choose the right tool, right? So this is where the Astra BD search documents tool was chosen. And then you can see that it's summarized sort of a query to pass into that tool. So that's what's going on here. You can see the tool call actually happen. This is a description of the tool that you saw Alejandro kind of add and set up initially. And then if I look at the attributes of the tool call itself, you can actually see what's returned, right? So these are search documents, ran a query against the Astra DB, and then fetched these kind of 3 documents that you see here. So you have the file path and then the actual document itself that are captured here as well. And then the final step of that process is it passes all of that information to the LLM, the agent again. So again, here's the system prompt, user question. Now we have more information that's been curated here. So we have the tool call, the data from the tool call itself, and then finally the summarized answer from the agent itself. So it's successfully been able to pull a RAG retrieval from the vector store, curate the answer, and basically provide a response using that data. So this gives you that kind of key observability. You can understand what's going on. It's kind of an important thing. So now that we kind of have clarity about what the agent is doing, we can focus now on measuring and improving the quality of our agent and sort of doing that. So the key step for that, or what's involved in that, is really starting with kind of the idea of a ground truth data set, right? So we have kind of built a prototype or framework, and now we want to actually test this against, in this case, it's a benchmark data set, the squad data set, that we can use to run and test these. These data sets themselves, our ground truth data sets, can actually be curated from benchmark data sets. They could be synthetically generated data, or even human generated data set. Doesn't take a lot to get started and actually getting some quality data to test with. But in this case, this is what we're working with here. So what we'll do now is actually jump into our notebook, and we'll show you how we create this data set, upload it to Arize, and then basically track and run experiments and then see the results of those experiments. So I'm going to walk through the notebook here, and this is going to be supplied as well as part of the webinar. So the first step is, in this kind of example that we're going to run here, we're prepping a data set. As we mentioned before, we're using the squad question and answer benchmark data set here. So we will go through that, a couple examples, gather what we need there, and you can see some of the details there. Next, we install modules for the rest of this kind of code-based example. So we're going to use Langflow, and this is going to be all running locally. So we're going to leverage kind of the runtime to execute those flows that were designed in UI. We're going to do that programmatically here. We're going to use Arize Phoenix to actually run our evaluation. Pandas are data frames that we're going to be used to format the data, and then we're going to use OpenAI as LLM as a judge to do the evaluations themselves. So that's kind of the what module we'll need. So the first piece here is we're going to load the ground truth from our benchmark so that we have the question and then the ground truth answer, which you see as an example in the data frame here. We'll load those up, basically initialize the client, Arize client here with our API key information. Run this command. This will actually create the data set in Arize. And in this case, we're using the squad data set of 100 examples. We also can leverage kind of smaller data set for kind of quicker tests as well and experimentation. So we've got 2 different data sets that we're running here. And then next, we're going to define the Langflow flows based on the code. So we're creating a function here that's going to basically execute the Langflow runtime, and that will pass the data set questions into this run flow, and that'll generate the output that we'll then use for our kind of experiment. So next step here is then we create an experiment with Langflow and Arize. So we define a task used to run this flow on the data set. That's going to allow us to pass the data set, run those against the flow, generate the output response. We create LLM as a judge here. So we initialize kind of what we're going to do. We're using OpenAI 4.0 Mini in this case to judge the outputs and compare those to the ground truth. And then here we're going to leverage Phoenix of evals, which are the Arize open source framework for evaluations. And to give you an idea of sort of, if you're not familiar with LLM as a judge, effectively, we are using an LLM to judge the output of another LLM response, right? Or an agent response in this case. This template is what we're passing to the LLM, and we're going to insert these variables, which are the question itself from the benchmark data set or the ground truth data set. We're going to get the response from the Langflow run that we run, and then we're going to compare that with a reference piece, which is going to be the ground truth. And if these are deemed to be if the output's deemed to be relevant to the ground truth in answering the question, it will respond with the correct label. If it's not, it's going to respond with an incorrect label. So we go through that process, run that experiment across the entire data set, as you can see here, and then that's going to log all of the data to Arize and post that there. So this allows us to kind of be able to run multiple experiments. When we actually ran these experiments, we were doing a few different changes, based on kind of like the size of the embedding model, the number of documents retrieved, et cetera, and the LLM used. So what that looks like basically after the experiments are run is we will track this data set in Arize. Here's the initial data set that was uploaded. I'm just going to show you the examples. So there's 100 examples of the squad data set with question and answer. And then here are all the experiments that were run in code that I showed you earlier with testing different LLMs, different sort of parameters or configuration settings within this to kind of see how this impacts the answer correctness, right? So the label's been provided here, and you can see a number of experiments have been run. So I'm just going to filter down so we can actually look at a few just to focus in. And in Arize, what we can do here is actually compare the results that we've measured here. So what you're looking at in terms of these mean average are basically the answer correctness evaluation that was run and the percentage of correct answers basically, or the accuracy around that. So if I highlight these three just to kind of look at these individual ones, I can now get a comparison view, comparing the different runs, these experiment runs that were run. So here's number 4 using a small embeddings model with 4 documents retrieved using GPT-4.1. And then you can see some differences here where we're using one document retrieved with GPT-4o, and then 4.1 nano is used here as well. So you can see the performance is generally the best here at 83% correctness with this particular model. That looks like it's GPT-4.1 there. You can also compare each row to see how that ground truth here on the answer compares to the different outputs as well as the labels. And then we do provide explanations. So the LLM as a judge is conducting kind of a reasoning task. So it will provide an explanation of how it came to create this label as well. So all of this is sort of explainability around how this label got created is built into the platform as well. So this is really useful because I think it can drive, your decisions. In this case, if we're going with the highest score, basically we have a good data-driven decision to use number 4 and these parameter settings when we're going forward in improving the agent. So I think at this point, what we can do now is also kind of show you what we can kind of do to continually develop or improve from here, right? So one of the thoughts here is that as I look through the ground truth, there's a few kind of these answers seem very short and not verbose, I would say, compared to the actual answers here, right? So kind of hypothesis here could be that if we shorten the answers and make them concise, this might actually help with improving accuracy as well. So what we could do here is we have a prompt playground to where you come in and basically experiment with system prompt and changes and basically test them and compare them with versions as you're testing side by side. So in this case, I have the original sort of prompt that we were using earlier. You can see this loaded here. I've saved this into our prompt hub, so all of this can be, you can save different versions and test them across different data sets. And so what we'll do is load the data set. I've got the prompt loaded from the original prompt that we tested with here. You can see those loaded here. And now what I can do is actually run this against the original system prompt and then each of these questions. So what's happening is it's going to test, it's going to actually run and produce some output here. And since our task, or kind of our goal, is to kind of make this more concise, we can see that these responses are quite wordy, quite verbose. So let's actually refine and iterate on this, right? So what I'm going to do is pop open a new prompt kind of window here so we can test. This is our A prompt. And I want to actually generate a new version, which is our B prompt. I'm going to preload version 2 just because it's kind of got the change I want already there. All I'm doing here is I'm adding to the original prompt an instruction to just say, hey, please respond with short and concise answers, right? Or please respond with that. And I'm going to rerun this. And if I run again, it's going to generate the output again for both A and B. And now we should be able to see the difference, right, between the original prompt I started with, the change of the prompt for the second one here. Let me just put this away. And so I'm just going to quickly peruse through this too. So we can see A is really long. Yeah, it is shorter, right, with the new prompt, with that new instruction. Let's just keep going through, and I can kind of eyeball and see that, yeah, it actually is shorter responses, but it's still not quite where I really want it to be. It's still a bit too verbose. And I also see that there's numbering going on. So it might be pulling in, different topics or different areas and trying to summarize, each of those. It's making each one of these bullet points basically a bit smaller, but it's still not concise. So let's iterate it on this one more time. What I'm going to do here is pull in version 3. So I'm just going to go ahead and say, and add another line here that says, hey, let's actually only reply with one primary fact that answers the question, right? So it's going to hopefully limit and choose one of these facts and then answer the question directly with that. So I'm going to rerun this again. So now we've got our A, B, and C prompts that we can compare side by side, how they're doing, and kind of make sure they're doing what they should be. And just by kind of looking through really quickly at high level, you can see we start with this and we end up with kind of a very concise response, right? A shortened response that's closer to what we're looking for. And you can kind of see that progression. So this is great. It's improving in the direction I want. I've been able to kind of quickly iterate very quickly, as you can see here, through a UI. So anyone can come in as you don't even have to be someone technical. You could be kind of a non-technical user and actually run and test and help in the development process. And so once I'm happy with this, I can save this prompt to our prompt hub. And then we can actually access this if we want to through APIs. So you can always be dynamically pulling in the right prompt or the most updated prompt as well in your workflows. So with that, let me go ahead and hand back to Alejandro, and we'll continue the workflow here. I'll stop sharing here.
All right. Actually, Rich, there was one question in the chat. Somebody had asked about both tracking token usage and tracking API costs. I had dug up a little link to some token counting, but could you speak to that a little bit?
Yeah, absolutely. We do track token counts as well and latency as well. So those are all things that are kind of native to the type of data that we do collect from the LLM itself in response. So those are things that you can create actually alerts on to monitor, and if your token counts start to go higher than your expected allotment or anything like that, we can alert on those as well. So completely built in.
Great. Let me 1 second. I'm going to find my screen to share again. it is. All right. And there was one other question about, how to deal with kind of, how many choices there are for kind of LLMs out there and how this might help with that. Um, you know, there's still a bit of work to do here, but one of the things I want to kind of highlight, that we were doing in these experiments is, trying to address that a little bit. So you can see we've named the experiments after the model used. So against this data set, we've tried, 4.1 mini, GPT 4.1 mini, 4.1 nano, 4.0, the full 4.1. You could kind of try more and kind of actually iterate through the whole set of kind of OpenAI models. And if you look at these experiments, like the highest one actually is the 4.1 model. The lowest one is the 4.1 nano. 4.0 and turns out 4.1 mini kind of performed about the same. So you can really kind of start to kind of get some insight here. And one thing I'll highlight in the code as well, if we jump back over to the GitHub notebook, and I'm gonna scroll really fast because I want to get all the way down to the bottom. The Langflow API has a thing called tweaks, and I'll show you how to do this in the next section really quick. But essentially, in code, you can actually modify the experiment to use different models, right? So you can kind of override the model that was selected in Langflow and tell it, hey, I want to use GPT 4.1 mini instead. So in this way, you can kind of iterate over a large number of models and generate a large number of experiments kind of programmatically to kind of assess kind of what happens with my particular data set with a lot of different models.
Yeah, I love that. It's just the ability to make quick changes and run them on a corpus of data quickly to compare, which is really great that you can do that. And the goal is to iterate quickly, make changes, test different models, test different settings, run those experiments, get the data quickly, and then be able to see like quantify what that impact is. So LLMs are one thing, but different depending on your use case. You might be looking at different kinds of other parameters that you might be changing. So that's great that you guys have that feature.
Great, thanks, Rich. Yeah, and then if I look at popping back over to Langflow, the way you can kind of find these tweaks is you click publish and you click API access. This shows you how to call kind of Langflow has both the editor, but it has a backend runtime that has a RESTful API service. There's Python, JavaScript examples, as well as like a curl. And then if you click this tweaks, this is how you can kind of do this. You can come in, you can say, hey, I want to change the orchestrating agent, and I want to, where's my model list? I want to change to GPT 4.1 nano. And then if I close that, if I come back over here, you can see it showed me kind of how to change the payload code to actually do that. Another question in there about running local models. Answer is yes, there's a couple ways to do that to avoid kind of OpenAI costs. One, we support OLLAMA, so you can use OLLAMA and set it up and kind of deploy local models. There's also a Hugging Face component for running kind of open models. And then the other piece is you've just deployed a model yourself locally. What am I looking for? There's an MCP server one, but there's also a, there we go, API request. So, let's say you've just kind of deployed a model locally or somewhere, and you want to just like call it with like a RESTful API service, you can kind of do that as well. So there's a lot of different ways to kind of do that. And if you come here on the agents themselves, so we have, let me zoom in a little bit. So we have kind of all of our various model providers that we have kind of fully integrated, but you can also have a custom model provider, right? So there you can plug in OLLAMA or plug in a custom call to kind of that's API compatible to use a different model.
Yeah. Yeah, and on the Arize side, the same applies. So you can bring your own custom models as well, or your own local models to the platform to do the evaluations as well. So very flexible there, same process.
And so the last bit here that I wanted to show everyone is, so if you remember before when we kind of built this chat flow, we set it up to say, hey, only answer questions from the tool you have. And so if I ask about a Dave Matthews Band song, I can't answer it because I don't have a Wikipedia article about Dave Matthews Band in my data set. So, if we want to expand this a bit so we can kind of answer any question, we can pull in a web search component. And we have one available in Langflow that's called Tavily AI Search. You do have to go sign up for an account with them. I've already done that and kind of made like an API key. So if we do that and turn this into a tool and then connect this into our agent, we now have kind of an agent that has multiple tools and needs to select from them. So let's see what happens if we do this. So let's go back to our question that we had before about the Dave Matthews Band, where it said, I don't have that information. And let's ask that question again. Okay, now you can see it's decided to call kind of for a Tavily search. And it provides an answer for that question. Now let's, check our kind of ground truth data set again and see what happens when we ask our question about the first Huguenot to arrive at the Cape of Good Hope. So when we do this, we see that kind of unfortunately it's going to the web to find this. But we've spent all this time building, a vector database with highly curated data that we know is really accurate. And so we really would prefer that it is using that information. So let's look at a way that we might be able to address that pretty quickly. So let me come and we will modify kind of these tool descriptions a little bit. So for Tavily, what we want to say is, okay, this tool, general web search to answer questions. And specifically, I'm going to kind of tell it, hey, let's see if you can just use this tool when, your other data tools are not able to kind of provide provide the information you're looking for. So we'll make those changes to Tavily. And then on the Astra DB side, since this is a tool where, we've curated this data set and we really trust this data set, let's add some language here that says, just try to use this one first to solve your problems. All right, let's see if that is able to actually solve our problems. So let's ask our Huguenot question. Okay, we do see that it's using Astra to do the search now. And it arrives back with an answer. And we can see that it searched and got some records back from Astra. And then let's see what happens if we try our Dave Matthews question one more time. All right, we can see that it is searching Astra. And we know we don't have any information in Astra, but then it's now searching Tavily, right? So it ran the search on Astra. It got back some vector data, did not answer the question that it was looking for. So then the agent decided that it was going to go off and try a second tool call to look for the Dave Matthews information, right? So just want to show that you can connect multiple tools in here. You can, the agent can decide to kind of call the tools multiple times. Luckily, we didn't have any breakages, but like actually when Rich and I were building this out, there were sometimes the Tavily search would time out and the agent will actually just retry a second time or a third time. You can control how many times it does that. That's a parameter in the advanced controls here. But it will retry to try to get the data and information it's looking for. And then if we come over into Arize, let's see if I am able to find what I'm looking for. I'm hoping to find one of these queries that has kind of multiple tools. So you can see here is one trace where we've got kind of the Tavily search component kind of showing up in the execution path. And then if I come back, that's the, yep, and this is the Cape of Good Hope one where it was using Tavily search. So again, we can kind of get a bunch of information here on kind of what happened. And if we look at some of these longer running queries, they're probably more likely to, you can see here in the longer running query, because it took 16 seconds, here you see it's using multiple tools. You can see the Tavily search component. You can see the Astra DB component. If you look at kind of the inputs and outputs on the chatbot, you'll kind of see, here's one where actually like some operation actually timed out on this particular one. But you was still able to kind of execute the final search and get a result.
And I like how you actually kind of focused on the long running latency items, because those were highlighted in red. And obviously, anything running 16 seconds there's a little bit of something you will probably want to dig into. So it's nice that you were able to kind of spot that and say, okay, I'm going to take a look at this 17-second query and see what's going on there.
Yeah, okay. And I see one last kind of question in Q&A asking if there's like a certificate or partner program for Arize and DataStax. There is not any kind of like official program, but you know, I think, you know, both of our teams are reachable. If you go to our websites, you know, like contact like support or help there, use, you know, the chatbot, you'll get in touch with someone who can kind of help you with what you're trying to do. If anybody has any other questions, please put them in the chat or the Q&A session now, as we're kind of coming up on the end here. But this was mostly what we wanted to show. And I'll pop up this QR code from.
Yep, that's so if you scan the code, that'll take you to Arize. You can get started with Arize, free trial or basically set up there. We do also have an open source development tool called Phoenix, completely open source, free, has some of the functionality that you saw earlier, minus the kind of monitoring, the more production side of features. But if you're just developing and you want to get sort of your hands dirty and just kind of try some of these experiments, prompt playground, a lot of the development side of the tools that I was showing today, Phoenix has that as well. So feel free to click on the links, scan that if you want to get started.
Great. So yeah, thank you so much, Rich, for joining me and helping me with this today. That was all that we wanted to share with everyone. So thank you everyone for joining, and you know, please follow the links to get any more information and get hands-on with all the tools.
My pleasure. Thanks for hosting this. Really liked it a lot. Thanks, Alejandro.